Hello everybody. So let us continue with this chapter 3. All right, so I've given you the basic integration and basic differentiation. So now let us discuss a few definitions first of all. Okay, so the first definition we're going to discuss is distance. All right, and I'm sure that this is nothing new to you. So here in this chapter, which is the motion in a straight line, okay, what is a distance? All right, so distance is basically the length of the path covered by a body. It is also called the path length. All right, so it's just basically the length of the path covered by a body. So for example, let's say here in this diagram, let's say, let me just draw something. Let's say a body is going from, let's say, from point A, and this body is traveling along this path, and then it is going like this, and finally it reaches point B. Okay, so to find the path length or the distance of the body, what you would have to do is you have to measure each section. All right, so you have to take a rope, and then you have to line the rope like this. From point A, you line it along the path, exactly along the path until you reach point B. Okay, and then what you do, you straighten the rope, and then you measure the length of the rope. So that would give us the path length or the distance traveled by the body. All right, but this is a case where the body is traveling in two dimension. Okay, two dimension, right? Now suppose if a body is traveling only in one dimension means the body is traveling in a straight line. So the body is going from point B, because now we are talking about motion in a straight line or a one-dimensional motion. Here it is a two-dimensional motion. All right, so basically it is just the length of the line AB. Then that will give us the distance traveled by the body, or the path length of the body. Okay. All right, so our next definition that we will discuss is the displacement. Now what is a displacement? Displacement is defined as the change in position of a body. If a body is at x1 at the time t1 and at x2 at another time t2, then its displacement is denoted by delta x, which is equal to x2 minus x1. Okay, so here let me just explain to you. So in this case, this is the initial position of the body, right? We call this point A as the initial position of the body, and point B, this is the final position of the body, and this is when the body is going in a two-dimensional diagram, in a two-dimensional space. Right, so basically from this position A, it has shifted to position B. So what will be the displacement of the body? The displacement of the body is simply a line joining the two positions. That means a line joining the initial position and the final position. So how do we do that? We'll just take a line from point A to point B, and in which direction? In that direction. Okay, in that direction. So this line AB will simply give us the displacement of the body. Okay, now in one dimension, on the other hand, you can see that here A here is the initial position. Let me write IP, and B here is the final position of the body. Now the displacement of the body, what did I tell you? It is simply a line joining the initial and the final position of the body. So if the body is going in a straight line, then the displacement will again be equal to the line AB. Okay, so we have one very important point, that in one dimension, in one dimension, the displacement is basically equal to the path length. Is this clear? In two dimension, is the displacement, that means the line AB, equal to the path length? Obviously, the path length would be greater than the displacement. Yes or no? So let me put a side note out here. So in this case, in two dimension, the path length, this will be greater than the displacement of the body. So that's in two dimension. But in one dimension, that means in a straight line, A and B. Okay, so that is one thing that you have to be very clear about this. All right. Okay, then what else? Let us continue further. Average speed. How do we define average speed? It is defined as the total distance divided by the total time. That is, average speed is v bar. All right, you can see here it's written v bar. This is not the vector sign. Okay, this is the sign for the average, or we can write v average, that is equal to total distance divided by the total time. All right, so okay, so in this problem, we have a body which is traveling 50 meter in 10 seconds, 20 meter in 3 seconds, and 60 meter in 8 seconds. Calculate the average speed of the body. Okay, how do we do this? Now, to find the average speed, all we need to do is to find the total distance. Plus 60, so that becomes how much? So basically 50, and this will be 70, 130 meter, and the total time. Total distance by total time. Yes, and here total distance is 130, and so how much this will be if you calculate? Is approximately 6.2 meter per second. Okay, so that is our first example. Let me give you another example. So in this second problem, we have a car that is traveling with 30 km per hour in 1 hour, 40 km per hour in 1.5 hours, and 50 km per hour in 30 minutes. Calculate the average speed of the car. Okay, so how do you do this? So in this case, you see the speed of the car is given and the time is given. The distance is not given. So here, v1, which is the speed of the car in the first interval, this will be 30 km per hour. H v3 is 50 km per hour, while t3 is 30 minutes. 30 minutes. All right, but then the times are all in hours, so 30 minutes is nothing but 0.5 hour. So therefore the average speed, this will be what? Total distance. Total distance means s1 plus s2. Yes, you know the distance is denoted by s, is it not? By total time t1 plus t2. Yes, I think you know this formula. We know that s is equal to vt. Yes, so from here we don't know s, but we know v and t. So instead of s1 we can write this as v1 t1 plus, and instead of s2 we can write v2 t2 by t1 plus t2. Okay, so here what is v1? V1 here is 30 and t1 here is 1. T3 divided by the values of v1, t1 and so on and so forth. You find what is the average speed. Got it? So I will give you one homework. You have to try this by yourself. I will not tell you the how to do this, but then you'll have to try it. Okay, let's say you have let's call this homework. Okay, you have a car let's say 100 meters. Okay, and with covering a distance of, let's say, 120 meter. Calculate the average speed of the, let's not say the car, let's say the body. Okay, because 50 meter per second, that is quite slow for a car. Okay, let's call this a body. So this you do as a homework. Okay, now so we have done the average speed. Now let us go to one more definition, the average velocity. Now what is the average velocity? It is defined as the displacement divided by the time interval during that displacement. Okay, so average velocity is denoted by this. It is displacement divided by the time interval. So here the displacement is x2 minus x1 and the time interval is t2 minus t1. And x2 minus x1 is denoted by delta x, t2 minus t1 is denoted by delta t. Okay, now this average velocity, I want to do one graphical interpretation. Before we discuss the graphical representation of the average velocity, I want to discuss something first, and that is the slope of a line. Slope of a line. Now, how many of you knows the definition of the slope of a line? Okay, in a graph, suppose the y-axis and this is the x-axis, right? And this is point O. Then you can have a line. Let's say you have a line somewhere like this. Let's say a line AB. Okay, so this is the line AB. Now, how do you define the slope of this line AB? All right, now the slope of a line of this line AB is defined by the tangent that this line AB makes with the horizontal or with the x-axis. So therefore what we must do is, from this point we must draw a horizontal which is parallel to the x-axis. Okay, so let's say this is the horizontal, all right, and this is making an angle theta. Okay, it is making an angle here theta with the horizontal. Okay, so let me complete the diagram. So just for convenience sake, let us draw another perpendicular line here. So you have right angled triangle. Okay, let me take this brush size to be smaller. Okay, right. Okay, so let's say this is point C. Okay, so here the slope of a line, slope of the line AB, this is defined as what? As the tangent. Tangent means tangent of what? Of the angle that this line makes with the horizontal, with the x-axis. And which angle it is making? It is making an angle theta. So this will be simply tan theta. Understand? So tan theta, we know that this is a right angle triangle, so tan theta will be perpendicular BC by the base AC. Okay, so that is the slope of a line. All right, and here, since theta here is a positive value, we imagine theta to be rotating and anti-clockwise. Okay, so here, since theta, in this case, no, since theta is acute means less than 90 degree, then tan theta, this will be positive. Okay, so a line which goes in this direction, which goes this way, we say that it has a positive slope. Okay, what about a negative slope line? Let's say again another graph. Now the line is going this way. Okay, it is going that way. Y, X, this is AB now. So AB, if you draw the horizontal, you have to draw the horizontal from here. Right? So let's say this is the angle theta that it is making. And here, what is happening? You see, so this angle theta is rotated graph, something like this, and this one is, so in this case, what will be the slope of this line? It is neither going up nor it is going down, so it's just going straight, so the slope of the line will be 0. Go into the definition of the average, before we discuss the graphical interpretation of the average velocity. So this one you can write it in the bracket. Can you see this red bracket? So this is not part of the answer. This is just a side note. Okay, so you can write this in a bracket. Okay. Okay, so let's say we have the graph for the motion of a body as shown in this graph. So let me draw the position time graph of motion of the body. Okay, so let's say this along the x-axis I'm taking the time, I'm measuring the time, and along the y-axis I'm measuring the position of the body. Okay, and that position is denoted by x. Color. Okay, let's say the graph is something like this. Okay, so let's say that is a graph of a body. All right, so this is just a graph that time t1. Okay, and we drop a perpendicular from point P on the position axis, it will give the position of the body. Alright, so let's say, let me take a rubber here and let me reduce the size. Yeah, that much. Okay, so here this P, that means at time t1 the position of the body is x1. Okay, so basically from here till here is x1 and from here till here is t1. Then at some other time, let's say at some other time t2, at some other time t2, what will be the position of the body? How do we get that? From this point we drop a perpendicular on the position axis. So let's say x2 is the position of the body. Okay, and obviously this is not the real graph, so the only real graph here is the pink color graph. So these are just the extra lines that I'm drawing, so that is why I'm giving it with a dotted line. Okay, so here we want to find the average velocity within this time interval. That means in this time interval from t1 to t2, that time interval. Okay, so what will be this time interval? You see, from 0 to this point, that is t2, from here till here, that is t1. So only this gap will be what? Will be t2 minus t1. Similarly, from here till here, that is x1. From here till here, that is x2. So only this gap will be what? Will be x2 minus x1. Yes or no? From here till there, that will be, let me use a eraser a little bit here, this will be x2 minus x1. Okay, so we want to find what is the average velocity in this time interval. So that means when the initial position is P and the final position is Q, what we do here is we just join so that we get the displacement of the body. We join from the initial position to the final position. So let us join this with a straight line there. So PQ, the line PQ, basically gives the displacement of the body during this time interval. Alright, so let us complete this diagram by dropping a perpendicular here. So again, this is not the real graph, so I'm just going to put dotted lines out here, right? And you can see that this line PQ, the displacement PQ, it is making some angle theta with the horizontal. Okay, let's name this point as R, and so on and so forth. Okay, that's enough, right? So by definition, what is the slope? Slope of PQ. Slope of PQ is nothing but, okay, let us go like this. Let us start with the definition of average velocity. How do we define average velocity? Average velocity is nothing but displacement divided by the time interval. So here, average velocity is displacement. Displacement is delta x by delta t. Okay, and what is delta x? Delta x here is x2 minus x1 by delta t here is t2 minus t1. That is how we define the average velocity, is it not? And here x2 minus x1 is not this line in the graph. This line here is equal to the line QR, to the side QR rather, and t2 minus t1 is equal to the side PR. Okay, but what is QR divided by, QR divided by PR? Isn't this perpendicular by base? Right, perpendicular by base, and that is nothing but equal to the tangent of the angle theta. Okay, and by definition, tan of the angle theta is nothing but the slope of the line PQ. You see here, so therefore we have the average velocity is nothing but equal to the slope of the line PQ. We have ourselves here a very important conclusion. Okay, so you can also define the average velocity as the slope of the line, the slope negative or zero slope, so that means the average velocity can be positive, negative, or zero as well. Let's call this example number 1, and let's say you have this graph, something like this. All right, and here this line OA and OB, they are the position time graph for the body A. Here, which one is traveling faster, body A or body B? Yes, that is a question. Which one is traveling faster? In other words, which one has higher average velocity? Time is a none. So obviously hill A for this. On the other hand, I have something like this. Okay, so let's say this body A is going, let's say have let's say the body A, and this is body B. Okay, all right, so here, can you tell me which one is having negative average velocity, A or B? So how do we know? We look at the slope once again. So it is very clear here that the slope of A is negative, so therefore A has negative average velocity, B has positive average velocity. Okay, and negative average velocity means that A is traveling opposite to B. It means that this body A, maybe it is going this way, and the body B, it is going that way. All right, so if these two are coming from here, let's say B is coming from here going that way, A is coming from here going that way, then obviously they will meet at some point, yes or no? This is the point where they meet. Okay, they meet at some time t. All right, and they are at a certain position at the point from the origin at the time when they meet. All right, so this I will talk about this nicely in when we discuss relative velocity. Okay, we are going to make use of this graph. Got it? Let's go some more. Let's say I have this kind of a graph. Example 3. This is xt, position time graph, and let's say something like this, and then like this, then like this, then this will go down, and then it'll go up. Okay, yeah, something like that. All right, and let me draw. Let's say you have this interval, then you have this interval, then you have this interval here, this interval, so on and so forth. So let's say this is our interval A, this is interval B, that's interval C, and this is interval D. Okay, so here you have to tell the nature of the speed. All right, the nature of the speed. Now if the graph is true for average velocity, then it will be true for average speed as well. Okay, so let us stick with average velocity out here. So if it is true for average velocity, then it will be true for velocity in general. All right, so here you have to tell at which interval will the velocity be positive, negative, zero, or maybe and where it is maximum. So how do we know? We just look at this graph out here. At this point, if you look at this point here, the graph is flat, right? So that means there is no slope. So that means at interval A, what is the average velocity here? The average velocity here will be 0. Okay. At interval B, the average velocity here, this will be positive. Why? Because you can see that this part is going up. Yes, it is a positive slope. At C, I think you know what it is. At C, the average velocity here will be negative. And where it is maximum, now if you look here, this slope and that slope, both the slopes are positive, right? That means at interval B and interval D. So they are both positive, but which one is more slopey? Which one makes a larger angle? Maximum.